How do we know how much energy we need in the future?
We know in part because science has a rigorous system for finding things out called statistics.
Statistics are kind of like putting together the pieces of a puzzle.
First, you describe the data that is like the puzzle you think you want to create.
Then collect data through surveys, experiments, and samples.
Those are the pieces of your puzzle.
Then you put together appropriate conclusions from the information you collected.
To make a projection about future energy needs, you need to look at the past statistics.
Things like how many people used how much energy in the past,
and how much the percentage of energy used grew or shrank with the use of new technology.
Population growth statistics are also important. How fast is the population likely to grow?
Statistics on past financial growth matter too, because wealthy people use more energy.
Let's start with 1965. Population 3,334,874,000.
These are approximate population statistics ending with the current year 2015 at a population of about 7,355,000,000.
From these numbers, statistically you can figure out the population grows on average about 1,206,000,000 every 15 years.
Divide 1,206,000,000 by 15 and you will find the average per year is 80,400,000 in population growth each year. So unless something big changes, population growth, you can statistically project a future population of 2030 to 8,561,000,000. That's a lot of people. If we were to put these statistics on a graph, it would look like this. The chart helps you visualize growth or decline. This is another kind of statistical graph. Each color represents the percentage of energy from a different source. Energy is measured in watts, joules, and other units. This chart measures world energy consumption by MTOE, that is, million tons oil equivalent. Statistical energy use from the past projects a future demand of about 17 MTOE around this year 2030. In the long term, the current energy system can't guarantee a reliable energy supply. The constant population growth and growing tech use is causing worldwide increased demand. We found a great article by Ryan Carlisle on Forbes Tech Online. Carlisle says some OPEC reserves figures have not adjusted down for 20 years without any new finds. Let that sink in. We really have no reliable data on how much oil is in reserve. Carlisle's Forbes article says there are 54 years of oil left if we kept using at current rates. Many scientists think there's an alternative energy source. Dun dun dun, dun dun dun, ding. So, on the right, we see our total non-renewable energy in reserve, including oil, measured in terawatts. Non-renewable means when it's gone, that's it, show's over. On the left are mostly untapped renewable sources of energy. Look how much there is available every year. The hugest source of renewable energy is the sun. Each year, the sun puts off 1,437 times more energy than the world's needs. Although no one really knows why, the data is clear that the Earth is definitely getting hotter. Actually, in my opinion, this chart looks like an out-of-control heart rate. Totally! So what this means is desert areas with lots of sun and little overcast or rain are likely to grow. The week we concluded the statistics project, the New Zealand Herald had an article on this very topic. The article suggested if New Zealand could build a solar farm 12 kilometers by 12 kilometers, it could generate enough energy to replace our current energy used from coal, oil, and gas.
If Australia built a 254 by 254 kilometer solar farm, it could supply all of the world's energy needs.
And statistically, the cost of solar is going down.
Recently, a very bold plan called Desert Tech was put forward. In this plan, the installation and construction of a network of solar plants in North Africa and the Mediterranean could supply power to Europe through the national grid.
The sun's potential is huge. The technology exists. Even the oil-producing nations have shifted towards the sun. Keeping in mind that we have no idea how much oil these countries have in reserve, this should signal a real need to seriously consider supporting investments in solar.
The United Arab Emirates commissioned a Swiss engineering firm to make a plan for the construction of huge offshore solar islands. The oceans have a larger percentage of high sun areas than deserts. There's also an abundance of salt water these plants can turn into fresh water. Water can also be used to store energy as hydrogen. Water to make steam and drive turbines.
Each sun island is expected to produce many gigawatts.
Solar farms are getting easier and cheaper to install on the tops of factories and schools.
Hint, hint.
So even we can join the solar revolution by putting small solar farms on unused roof space. With the power of statistical data, companies, countries, cities, and individuals can get a clear idea of what patterns existed in the past, what patterns are emerging now, where our effort or investment needs to go, and what this might mean for the future.
Statistics apply to a lot of life, like the miles per gallon on your car to your father's golf handicap. You can even play with statistics. Check out the iPad app Graphing for Kids by Red Hong and start taking your own polls and charting them. Statistically, what ice cream do your friends keep in the fridge to beat the summer heat?
I'm a vanilla fan myself.
You know what I wish? I wish there was a way to install solar cells into your parents, pop them in the sun for a bit to re-energize them.
I don't know. Mom's already looking pretty toasted after helping us figure out this animation software. What do you think of chocolate?
Yep, she needs lots of chocolate.